When you plug in a computer at home, you expect it to turn on and stay on. But if the power goes out, everything shuts down instantly. In a data center, that kind of interruption is not acceptable. Even a fraction of a second without power can cause servers to crash, data to be lost, and critical systems to fail. That's why data centers rely on one of the most important systems in the entire facility, the Uninterruptible Power Supply, or UPS. In this video, we're going to walk through how UPS systems work, why they are critical, and how they fit into the overall power chain inside a data center. Let's start with the big picture. Power in a data center typically comes from the utility grid. That power enters the building, passes through switchgear, and is distributed toward the IT equipment. But utility power is not perfect. There can be voltage fluctuations, frequency variations, and in some cases, complete outages. Even a brief disturbance, something as small as a split-second dip, can affect sensitive electronics. That's where the UPS comes in. The UPS sits between the incoming power and the servers. Its job is to condition the power and provide instantaneous backup power if the utility fails. Think of it as a protective buffer between the outside world and the critical equipment inside the data center. Now let's break down how a UPS actually works. At its core, a UPS system has three main components: a rectifier, a battery system, and an inverter. Under normal conditions, utility power enters the UPS and is converted from alternating current, or AC, into direct current, or DC, by the rectifier. This DC power is used to charge the batteries and also feeds the inverter. The inverter then converts the DC power back into clean, stable AC power that is sent to the servers. So even when utility power is available, the UPS is actively conditioning and controlling the power before it reaches the equipment. This type of system is called a double conversion UPS, and it is the most common design used in modern data centers. Now let's look at what happens during a power outage. If the utility power suddenly fails, the rectifier stops receiving input. But the batteries are already charged and connected to the inverter. So instead of switching over, the UPS simply continues supplying power using the batteries, with no interruption at all. This transition is seamless. There is no delay, no flicker, and no disruption to the servers. That's why it's called an uninterruptible power supply. However, batteries alone cannot power a data center for long. Most UPS battery systems are designed to provide power for a short duration, typically anywhere from a few minutes to around 15 minutes. That may not sound like much, but it's enough time for the next system to take over, the backup generators. When a power outage occurs, generators automatically start up. But generators are mechanical systems, and they take time to reach full operating speed, usually several seconds. The UPS bridges that gap. It keeps everything running while the generators start, stabilize, and begin supplying power to the building. Once the generators are online, they take over the load, and the UPS batteries begin recharging. Now let's talk about the types of UPS systems you might see. The most common in data centers is the double conversion UPS, which we just described. There are also other types like line interactive UPS systems, but these are typically used in smaller applications, not large-scale data centers. In mission-critical facilities, the goal is maximum reliability and power quality, which is why double conversion systems are preferred. Another important concept is redundancy. Just like other data center systems, UPS systems are often designed with redundancy levels such as N, N+1, or even 2N. This means there are additional UPS modules or entire systems in place so that if one component fails, another can immediately take over. In some designs, the data center may have two completely independent UPS systems, each capable of supporting the full load. This ensures that even during maintenance or equipment failure, power is always available. You may also hear about different battery technologies used in UPS systems. Traditionally, many UPS systems used valve-regulated lead-acid batteries, often called VRLA batteries. These are reliable and cost-effective but require space and maintenance. More recently, lithium-ion batteries are becoming more common in data centers. They offer longer life, smaller footprint, and better performance, but at a higher upfront cost. Each data center design will balance cost, space, and performance when selecting the battery system. Now let's connect this back to the overall data center power flow. Power comes in from the utility, passes through switchgear, then into the UPS system. From the UPS, power is distributed through power distribution units, or PDUs, and eventually reaches the server racks. If utility power fails, the UPS instantly takes over using batteries. Within seconds, generators start and supply power to the system, allowing the UPS to recharge and continue conditioning the power. All of this happens automatically without any human intervention. So, the next time you hear about a data center operating 24/7 with no downtime, understand that systems like the UPS are a big reason why. They are constantly working in the background, ensuring that power remains stable, clean, and uninterrupted. Without them, even the most advanced data center would be vulnerable to the smallest electrical disturbance. In the next video, we're going to shift from power systems to cooling and break down one of the most fundamental airflow strategies used in data centers: hot aisle and cold aisle containment. You'll see how airflow is organized, how it improves cooling efficiency, and why it remains a critical design approach in most facilities today, even as newer cooling technologies continue to evolve. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.